everybody, and welcome back to the Aquarium of the Pacific's Online Academy. We're very happy to have you all joining us this afternoon. This will be our last program of the day, and we hope to see you all back at 9 o'clock tomorrow morning. Now, my name is Dana, and I am two things. I am an educator here at the aquarium, and I am also a diver, both here at the aquarium and as often as I can out in the ocean, which is not as often as I'd like, unfortunately. But today, we are going to do a little bit of a recap on the science of scuba, something we did last week or maybe 2 weeks ago. We're going to talk about those subjects again, but then I want to really dive into some of the questions that you were asking last time. As you can see right down here, we do have that question number back on the screen. We'd love your participation throughout this program. So if you want to shoot us a text at any point, ask a question about diving, any of the animals I'm talking about, that number is going to be right here. It is 562-286-1838. And I'd really like to cater this discussion towards the things that you're most interested in. So again, we'll do a recap on some of the science of diving, and then I want to talk about what my day as a diver is like, maybe here at the aquarium, and also if I'm going to go do an ocean dive. So let's jump in, if you will. Now, the first thing we're going to do is we are going to check out some footage of our blue cavern exhibit. I'm sorry, this is amber forest. So let's hang out here. So this is amber forest. This is one of our kelp forest habitats here at the aquarium. And what are some observations that you can make about this habitat right here? What are the animals doing? What is the water doing? What do you notice? Now, again, you can text in some answers to 562-286-1838, the number down there on the bottom. You can also turn to your family and friends next to you, share some of those observations. Remember, texting rates do apply. If you're watching this after the fact, you can also shoot us an email at live@lbaop.org. Once again, that's live@lbaop.org. I'm going to jump back in here and let's talk a little bit about some of the observations that I'm making. Well, I noticed that these fish are moving around quite a bit. Ooh, somewhere in here. They swam behind me, right? I'm also seeing that the kelp right here is also moving quite a bit. And you can see that in all of the algae that's on the screen here. And that's because there's movement in our exhibit right here, just because there's movement out in the ocean. All right, and so that's something that divers are going to have to deal with. But a little bit more about the fish. If you recall, if you've seen this program before, we talked a little bit about what a fish has that helps them as a fish, right? So they're living in the ocean. So how do fish breathe? Well, I'm going to pull up my little fishy friend right here, if I can find my fishy friend. And we're going to take a look at what makes this animal a fish. So once again, fish have gills, right? They're going to be back in here. And that's where they're going to get their oxygen. They're going to pull that oxygen from the water. Fish have fins to help them swim, okay? So that's going to help them move through the water a lot better than you and I, right? We have legs to walk around on land. We have a very upright skeleton. Fish, on the other hand, they cut through that water really nice. They're much better swimmers than we are. Fish also have eyes that can see underwater. What do our eyes look through? Well, we're going to be looking through air, right? I'm hanging out on land in air. And so our eyes are designed a little bit differently. Fish have scales to protect themselves from rocks and reefs all around them, protect themselves from the environment. And most importantly, fish have something called a swim bladder. It's an it's a gas bladder inside their body, and that's going to affect their buoyancy. All right, and that's something that we're going to talk about a little bit after we chat about the gear of a diver. So let's pull my friend Sherwood back in. If you recall, Sherwood joined us last time. Now, Sherwood's a little tall, so we're going to have to back up here. All right. And we're going to take a look at our dive buddy right here and talk about what makes our diver a fish for the day, right? What's it going to look like? So let's take a look. Well, we mentioned the fish has those eyes that can see through water. So our mask creates an airspace that's going to allow us to see through the water as well. If you've ever gone down in a pool or in a lake or in an ocean or any body of water and you've tried to open your eyes, it's really blurry, right? But if you have a mask or if you have goggles on, it makes it a lot easier to see. And that's because our eyes are actually looking through that air space that the mask provides. Now, divers also have probably some of their most important gear is this thing right here, right? So this is Sherwood's tank. And take a moment and think about it. Once again, what is inside of a diver's tank? Is it pure oxygen? Absolutely not. So if you think about it, are we breathing pure oxygen right now? I'm not. James isn't. Allie's not. Emily's not. Those are my friends who are hanging out with me inside the studio, helping make sure all of this goes smooth. And we are actually just breathing air. And air is not pure oxygen. Air is a mixture of a number of different gases. It's actually mostly nitrogen. And so it's about 78% nitrogen, 21% oxygen, and 1% of other gas. Okay. And so inside of this tank, it's just air that's around us, just like you sitting at home, but it's compressed and it's pushed down into this tank right here. So it's compressed air right on their back. Now that's important because they're dropping down underwater. And so they bring their air with them and then use this. This is called a regulator. It's going to go in their mouth and they're going to breathe off of that. And that's how the air from their tank is getting into their mouth, which goes down into their lungs, right? So they've got their air. We don't have gills. We have the lungs instead. What else did the fish have? Well, they had scales. So let's take a look at this. I mentioned that the scales were there for protection from the environment, right? Well, humans don't have scales. Our skin's pretty thick, but we want a little bit more for a number of reasons. The oceanic habitat can be a little bit different, right? It can be really chilly depending on where you're diving. I do most of my dives right here off of the California coastline, and it is very, very cold. If you're native to California and you've been in our water, you'll know the Southern California ocean is still pretty chilly, even in the summer. And as you go further north up the coast, it just gets colder and colder and colder. In fact, I got certified in Monterey Bay in March. I'll tell you what, it is freezing. And so for that certification class, I had to wear this. Now, this is a wetsuit. Okay, it's really thick. It makes a nice tight seal around your skin. And my biggest question for you right now, I want you to think for a moment. If it's a wetsuit, am I getting wet? Huh. A lot of people think that divers are dry when they're down there. But if you're wearing a wetsuit, you are getting wet, right? As it says in the name. The way wetsuits are going to work is water gets trapped in the suit between your body and the wetsuit. This is called neoprene. And your body heat is going to warm up that layer of water, and it kind of creates a nice little jacket. Now, sometimes you can actually get really warm on a dive, and those are really fun dives. And you can kind of flush the water out of your suit, get a little bit more cold water in there. I once had a sunburn, and I had to wear a wetsuit, and the whole dive I was just trying to flush cool water in and all around my body. That way I could kind of take care of the burn from that sunburn. And so this is our version of exposure protection, right? We don't have the scales. Instead, we do wear a wetsuit. Now, this one's pretty thin. This is only 3 millimeters, okay? So that's about that thin. If you're diving off the California coast, you're usually in at least a 7 mil, okay? So 7 millimeters. Sometimes they can be different. Sometimes it can be like 8 millimeter core with maybe 7 to 5 millimeter arms, just depending on how warm you want to be. Some people get colder faster than others. I am one of those people. Now, they also have fins. We mentioned the fact that our fish are really good swimmers. I did mention in the last program about scuba diving that I was a swimmer. I swam all through high school. I swam all through college. And even with 20 years of swim experience, the ocean can still really take it out of you. So divers wear fins, just like these right here, okay? And fins are going to help us move through the water a little bit better. That way we're not fighting the current. If you recall when we were looking at amber forests, there was a lot of movement going on. That wasn't the current. That's something that we would call surge. But divers are fighting that the whole time they're down there. They're getting pushed back and forth. They're fighting the currents. And so it can really wear you out, especially if you're starting to get cold, right? And so that's just a recap of all of our dive gear. Now, the reason this is important is because we're trying to turn ourselves into a fish, right? And the most important part about that fish that I mentioned before, I said we'd talk about it again, was that swim bladder. That's going to be that air-filled or gas-filled sac within their body. And that, my friends, will determine where a fish is within the water column. So if a fish were to be sitting on the seafloor, there's not going to be any air in that or any gas in that swim bladder. But if it's up on the surface, it's going to be really full of gas. And we'll talk about that when we talk about our gas laws. How does a fish hang out right in the center? And how does a diver hang out right in the center, right? So if you were all to jump into a pool right now, what's going to happen? Usually you sink to the bottom first, right? There's a lot of forces, you go down. And then you're going to spring back to the surface of the water. And that's because the average person in their birthday suit or a bathing suit is going to be what we call neutrally buoyant, okay? And they're going to be neutrally buoyant on the surface of the water. And that means you're not quite sinking, you're not quite floating, but you kind of hang out right on that level. All right. We're getting some questions here, which I'm really excited for. I'm going to wrap up our little recap here, and then we're going to turn to those questions because I really like what we've got coming in. Now, as the diver, once you jump in the pool and you bounce back to the surface, what happens if you're diving? Do you want to swim around on the surface the whole time? Definitely not, right? Most of the life is going to be down at the bottom or at least in the mid-water column. And so divers also wear a weight belt to get them down. But then if you're trying to get back to the surface, you're fighting that weight and you're really wearing yourself out when you're trying to float on the surface, right? And so there's a lot of things that divers have to factor in when it comes to where they want to be in the water. In fact, the sweet spot is just a couple feet above the sea floor. And that's because you don't want to be walking around and making a huge impact on all of those animals. Instead, you want to kind of hover right above them, okay? And that is what this jacket, or BCD, Buoyancy Compensation Device, is for, all right? This is a big kind of jacket-like structure that goes around our diver. And in here, there's air sacs, or at least there's air bladders that we can put air into. And so we kind of create our own swim bladder within our dive gear. And again, I mentioned buoyancy. If you were watching 2 weeks ago, we talked about the fact that buoyancy is the force that pushes up on an object. If you were to submerge an object in water, buoyancy is the force, and it is equal to the weight of fluid displaced by that object. So I did have a ping pong ball. There we go. So this is a ping pong ball, and it's hollow, right? It's not very heavy. It also means it's not very dense. It's very light density. And if I were to drop this in water, what is it going to do? Is it going to float or is it going to sink? Well, if I recall, it's going to float, right? And that's because the weight of the water displaced by this object is stronger or heavier than the weight of the object itself. So the buoyant force will be stronger and will be pushing it up. What if I were to fill this ping pong ball with rocks? Okay, all of a sudden it's really dense, it's a lot heavier. And as it drops into the water, the weight of the new rock-filled ping pong ball is heavier or stronger than the weight of the water that is displaced by the object, because the displacement is the same. Now all of a sudden the buoyant force is not as strong, and so it's going to sink. So that's where density and buoyancy kind of play hand in hand. And again, that's why divers have this buoyancy compensation device. They don't want to be so heavy or dense that they're on the sea floor, but they also don't want to be floating to the surface of the water. Now we're going to take a break here, and we can put Blue Cavern on the screen. Oh yeah, definitely. So this is a really cool picture right here. This is a diver underwater. You can actually see that weight belt right here. That's going to be that bright line going across. Looks just like a belt. You can see bubbles coming, right? You can see some lines. This is a spare regulator over here. The other one is in their mouth. You can see those fins that I was talking about, right? So this diver is hanging out in the ocean with a Humboldt squid. That's going to be this animal right here. Now, oftentimes we think of squid as being either a little market squid, something that we might get when we order calamari, or giant squid, which no one really has a whole lot of footage of, right? But this is a Humboldt squid. And this is not photoshopped, okay? Humboldt squid can get anywhere from 4 to 6 feet in length. This is not me. That would be really cool. I have never seen a Humboldt squid, but this is an example of a diver in the water. Now you'll notice they're not on the seafloor. They're not on the surface of the ocean. They're finding that sweet spot, what we like to call neutral buoyancy. Now we're going to take a look at some of these questions over here. One question we got was, do I have a favorite place to dive and why? That's a wonderful question. It's also really hard to answer. I used to be a huge advocate for cold water diving, something that you would find right here in California, for example. Like I said, I got certified in Monterey. I have done a lot of diving in Southern California. But then I moved to Costa Rica for a little bit and I did a lot of tropical diving, and it's pretty easy to get swayed. Tropical diving is a lot warmer, so it usually means a little bit less gear just because you don't have to have as much exposure protection. So one of my favorite places to dive is a little rocky pinnacle area in Costa Rica. It's called Los Catalinas or Los Clásicos. It's kind of a classic dive site at the Catalina Islands. Not the same Catalina Island that's off of our coast. It's very confusing, but it's another place off the west coast of Costa Rica. And I think I love that spot because there's this really rocky pinnacle. And so it's a boat dive. When you jump off the boat, you get to jump in the water, drop down about 65 feet or so, and then you just kind of swim in a circle around this big rock island. And I saw lots of different animals there. Actually, before we got in the water, it was a little disappointing. Before we got in the water, somebody came up and told us that they had seen a manta ray. By the time we actually geared up and got in, it had disappeared. But I did get to see a Goliath grouper. If you've ever joined us here at the aquarium before, you might have seen one of our Queensland grouper, which is up in our tropical Pacific gallery. And they're pretty big fish. They're bigger than I am. And so it was really special to see that animal. So I would say that's probably one of my favorites. The next question we got was, where are good places to dive in Southern California? And yeah, like I said, most of my diving is around here. A really popular dive site in Southern California is going to be La Jolla Cove down in San Diego. It's really unique because there's a stairwell that takes you right into, right onto the beach. It's got a little bit of a doozy as a last step, especially when you're trying to climb out of the dive. You're really tired afterwards, but La Jolla Cove's special because there's a lot of sea lions out there. There's a lot of horn sharks. In spring, they'll get 7-gill sharks that come into the cove, and so it's really special. You never quite know what you're going to see when you're out there, so I do love La Jolla Cove. I also really enjoy diving Catalina Island, another easy but fun dive park to explore. Let's see. Melody asked, can I dive anywhere in the ocean if I have a license? Are there any restricted areas? Melody, that's a really great question. And I love that you brought it up because another reason that California diving can be so great is because there are some restrictions in place. Those restrictions aren't necessarily on divers, but they are on the other activity that can be in the area. And so what I'm talking about is something called a marine protected area. And so a marine protected area is like a national park or a state park, but found underwater. And so a really common dive site down here, actually most of the dive sites down here are going to be marine protected areas. And the reason I said that they're so great is because of those restrictions you asked about. Marine protected areas usually are places where you can't fish or there's very restricted fishing. In fact, this exhibit that you see right behind me, this is our Blue Cavern exhibit. It's modeled after a marine protected area out at Catalina Island. I've never been fortunate enough to dive the real Blue Cavern, but they say it's really unique because you're not allowed to drop anchor when you're diving Blue Cavern, and it is a dive site that has to be done from a boat. And so the boat will usually drop divers off and then they have to go drop anchor or cruise around somewhere else while the divers are exploring underwater. So you can imagine there's some challenges that come with those MPAs, but for the most part, it creates a lot of life underwater for us California divers and anyone who decides to come visit to explore. Have I ever gotten stuck in surge? Yeah, Melody, I definitely have. Another kind of unique aspect of California diving is we have a lot of rocky reefs. And rocky reefs are different than coral, right? Usually when you hear the word reef, you're picturing a really beautiful, colorful, tropical coral dive site. However, we have rocky reefs right here. Now, this is kind of an example of some large rocks that you might find. All of the kelp involved as well. A rocky reef out off of our coastline is also going to be covered in all sorts of algae. So there's going to be fish all around, invertebrates like sea urchins and everything. And Shaw's Cove, another really popular Laguna dive site, just a little bit south of here, is known for, there's some like really shallow swim throughs or skinny swim throughs, I should say. And you have to be very careful with surge there because sometimes the surge can move you back and forth. I would be on screen and off screen. I could go all the way back and forth. And when you're diving through this kind of skinny place, that can get pretty scary. So you have to make sure that your buoyancy, like we talked about before, is really secure and you're really comfortable in that spot because it's easy to, whoops, accidentally go up too fast or drop to the bottom or hit a rock. So yeah, surge, I've definitely been caught in some pretty good surge. Gage from Arizona, I love that you're chatting in from Arizona, asks, can you scuba dive in open water far from land? Yes, you can. I haven't actually been able to do one of these. When I dove the Catalina Pinnacles in Costa Rica, you are pretty far away from mainland, but you're still around those big rocky pinnacles and little islands. But when you're diving in just open water, that's going to be something called a blue water dive. Or if you're really brave, you can do a black water dive, which is the same thing, but at night. I have done black water snorkels, which I was on the surface, obviously. I was snorkeling. For those of you who might not have thought about the difference, scuba versus snorkel. A snorkel is going to be like, let's see, let's bring Sherwood back over here. We're going to have to scoot him back, though. So a mask and a snorkel, right? This is just a little tube. You have to stay on the surface because your air is actually coming from the surface as opposed to having that tank on your back. Scuba actually stands for self-contained underwater breathing apparatus, right? So you're bringing that whole tank and air source with you. So a blackwater snorkel is a little bit different. I was just kind of contained in the very upper surface of the water to make sure I still had air. But blue water dives, black water dives, and any type of open ocean snorkeling can be really, really different than if I was diving a reef or diving a rocky reef or a coral reef or any other type of kind of like a kelp forest, anything like that. Because when you're diving open water, you don't really have a whole lot around you to give you perspective on where you're at. It's really easy to all of a sudden be way too deep or be way too shallow. Now, a couple weeks ago, I talked about why it's important to know your depth and not go up too fast. If you recall some of those gas laws, I can talk about them again right here to remind you. As you go down in depth, so if I'm deeper and deeper, there's more pressure on me, okay? So standing right here, standing in the studio, sitting on your couch at home, you all and we all are currently under 1 atmosphere of pressure. Now, even though it looks like I'm nice and free, I have the entire weight of the atmosphere pressing down on my shoulders, right? And that's fine. Our bodies are used to that. But when we drop down to 30 to 33 feet, drop down again, 60, 66 feet, every 33 feet you go down, you are increasing the pressure by 1 atmosphere, okay? So all of a sudden, there's a lot of pressure. And this is important when it comes to the gas. Remember I mentioned the air, okay? So as I'm breathing, if I'm at 66 feet, okay, the higher the pressure, the smaller the volume. Now, I take a breath of air at 66 feet. And then I'm going to hold it. And then I start to go up. And all of a sudden I'm at 33 feet, which means there's less pressure. If there's less pressure, what just happened to the air that's in my lungs? Well, it's going to expand, right? As pressure decreases, volume increases. And so if I'm holding my breath as a diver and going up, I can really risk some serious injuries. One of those being lung expansion, so much that my lungs theoretically could burst, okay? And so the reason it's hard to do that blue water or black water dives is you have to pay attention to what level. I point at my watch when I do this. My dive computer that tells me my depth is on my wrist usually. And so I have to make sure that even though everything around me is blue or black, I'm still hovering at 66 feet, right? I also have to make sure that I'm never holding my breath as a diver. Let's see, how deep can a scuba diver go? Yeah, that's a great question. As an average recreational diver, the dive limit is 130 feet. And that's fine. As an average diver, you really don't need to go deeper than that. In fact, I personally like to hang out between 45 and 60 feet. That's where you're going to find a lot of life because there's going to be light there still, right? So as you go deeper and deeper in the ocean, you lose light. And a lot of life depends on that light as a food source, right? All of our algae and all of our photosynthetic animals who are creating their nutrients from that sunlight, they need to have light. So as you go deeper, you actually lose a lot of life. There are divers that can go much deeper. There is technology, something that's a little bit outside of my scope, that does allow divers to go deeper. There's something called saturation diving. And This has to do with a lot more gas laws as well. As you go deeper, when you're breathing that air, remember I mentioned most of it is called or is nitrogen. 78% of that air is nitrogen. And nitrogen can be dissolved in your bloodstream and your tissues. And as you surface, that can actually be released as bubbles, which again is not good. So you don't want to surface too fast. But there is things called nitrogen toxicity. You can also get oxygen toxicity. I know we think of oxygen as like the life source gas, but too much of it can be a bad thing. And these are all other factors that divers have to think about. And so when I say saturation diving, it's a way of training your body to take those gases on in a different way. And if that's something you're interested in, I would highly recommend checking out a little bit more about it, doing some of your own research. Like I said, it's far, far outside of my scope. But they can go really deep, right? They can go down hundreds and hundreds of meters. Another one, there's different gas mixtures. Now, this is a little bit kind of confusing to really think about, but it deals with the pressure. It deals with those gas laws I mentioned. For example, you might have heard of something called nitrox. Nitrox is a little bit different. I mentioned the 78 and 21% that we normally breathe right now, like you and I. Nitrox is a different percentage mixture of that gas, and that can allow divers to go a little bit deeper, go a little bit longer. But the average diver, 130 feet. Have I ever barfed or gotten seasick while diving? I have not, and I've been so lucky. I do have friends who have thrown up in their regulator, which is not fun, okay? So the way regulators work, we're going to bring Sherwood back over here. That's going to be this right here. There's a little diaphragm in there that it's kind of a demand. So when I take a breath, it pushes, it's going to... Oh gosh, I'm really bad at explaining this, but there's a mechanism in there that's going to move out of the way and allow the air to come in. And it also prevents things from going back into the tube, which is good because when you throw up, you don't want it stuck in here. And yes, it has happened. It has not happened to me, thank goodness, right? Why does Sherwood wear a snorkel if they're a diver? Really good question. So you only have so much air in that tank on your back. That's one reason, right? So say it's an 80 cubic foot tank. That means that, let's say your average bathroom at home is about 80 cubic feet. The air that's in that room is compressed into that little space. And once you run out, you're out of air, and you want to make sure that you're getting as much diving in as you can. But what if the dive site you want to go to is 400 yards offshore, right? You don't want to, if you're doing a dive, that's really convenient. But if you're doing a shore dive, which a lot of people in California do, you're going to have to swim out there. So it's something called a surface swim, right? I don't want to get in and drop down in 2 feet of water and then swim all the way under, because that's going to, go through my air, and also it's easy to get lost when you're underwater, right? If you're not good at navigating. So by doing a surface swim, you can conserve your air, and Sherwood would use that snorkel while doing that surface swim. Which is really cool because actually I've seen a lot of fun stuff on my surface swims. I saw a stingray one time as it swam underneath me. I've seen some sharks swimming by. I've seen a lot of fish. So you can still start exploring even as you're doing your surface swim. But most of the time I kick on my back and I talk to my buddy. So, but that's why we have snorkels as well. Gabriel asked, how long does it take to become a diver? Really good question, Gabriel. I personally got certified through my university, and it was a very long, intensive course. It was about 10 weeks. You can go to a dive shop and get certified in like a couple pool sessions and maybe 2 weekends or so. It really just depends. I am a believer that your basic certification is kind of a license to learn to dive. So I always encourage people to learn a little bit more. The more classes you take, the more experience you gain, and the safer you can be as a diver. But it doesn't take long. And the beautiful thing is you can actually start right now. A lot of people think that to be a scuba diver, you have to be a marine biologist, or you have to live by the ocean, or you have to work in the ocean, or you have to have some tie to this. But your tie can be interest, can be curiosity, can be wonder, right? And you can become a diver at 12 years old. You become a junior scuba diver, but then you can explore the ocean as you go and as you grow, and you can just learn more and more as time passes. So I highly encourage anyone who's interested in that to check it out. Zoe asks, is there a reason why wetsuits are usually black? Great question, Zoe. I don't think so. I think that's just how it started. Correct me if I'm wrong. Aha! Neoprene is easier to color black. So there we go. Oftentimes when you see a colored wetsuit, let's see if I can bring Sherwood back over here. It's usually got the neoprene, and then it's sometimes it will have like a really thin material covering it, and that's going to give it that color. But yeah, for the most part, they've just always been black. You can get really bright color wetsuits, which is fun. On that note, I want to mention real quick, I know we're running out of time here. We talked about how when you're in a wetsuit, you are wet. Now, there is something called a dry suit, okay? And I'm going to leave this with you as a challenge or as homework, all right? Now, a dry suit, well, it keeps you dry. So what is acting as that insulation? What is between you and the water? Not just the material of the suit, but is it water or is it air? And if it's air, what other things do you have to factor in as a dry suit diver? So there you go, my friends. There's some homework for you to explore a little bit more about some of the challenges that divers might face. I personally am not a dry suit diver, but you stay warmer as a dry diver. So something to keep in mind. I really appreciate the questions you all sent in. I really love answering those. I love diving. So hopefully this kind of sparked your curiosity and you want to know a little bit more. Otherwise, thanks for joining us. Once again, if you're watching this after live feed, you are welcome to shoot us some questions still. Our email address is live, L-I-V-E, at lbaop.org. That's like Long Beach Aquarium of Pacific.org. So we hope to hear from you, and thank you all so much for joining us today. And we'll hopefully see you again tomorrow morning. Bye, everyone.